Hi everybody, this is Mrs. Dinkelman, and these are the notes for lesson 3.5, which is finding the derivatives of inverse functions. And we're going to use the example one and just kind of peek at Desmos to kind of get an idea of what's happening with the derivatives of inverse functions. It's sometimes a little bit difficult to explain without a visual, so we're going to kind of look at that example. So I need to get to Desmos, not that one. Okay, so they want us to look at the square root of x. So let's see, I have this kind of built so that we can change it to any function. So I'm just going to go x to the 1/2 here. Makes it a little bit crazy to look at, but I think we can get it done. Okay, so if I just kind of take off for a second, the red function there is the square root of x, and let's see if I can make him a little bit bigger. I don't know that I can, that's okay. And then the dotted line, or the blue there now, is the inverse of the function. Remember, the way we can tell that a function and its inverse are graphed is by looking at that y equals x line. So we can see that they're inverses. And then, and just by the way, again, we're looking at example one. It says find f inverse, and you must use a domain restriction. That's because if we just say that it's x squared, then technically it doesn't have an inverse because it has to pass the horizontal line test for us to say that it's 1-to-1 and onto. That means it has an inverse. Okay, so it's just part of x squared, just the positive part. We've sketched them both. We want to differentiate both. We'll get to that in a second. We want to find the slope of the graph of f at 4, 2. So I have built this so that we can slide, hopefully. Can we slide? Yes, to 4, 2. And maybe we can actually, I wonder if I can exactly get it at 4. Okay, let's do that. Perfect. Okay, so remember that a function at its inverse, when we're talking about a specific point, we're talking about kind of the, it's like a corresponding point. It's not the exact same point, but it's the point where the x's and y's switch. So you can see on the blue function then that it is 2, 4. Now I've also built the tangent lines here. Those are the dotted lines, and you can see for the first one, so at 4, 2, this red, that the slope is 0.25, so 1/4. And then the slope of the other one then is 4, which is actually just the reciprocal of that. So it makes us curious whether that is always going to be true. So maybe let's look and see what happens when we look when a is 1. So the weird thing here is that it's hard to tell that the corresponding points because it's 1, 1, and then 1, 1. But let's look at their slopes again. So for the red, it's 1/2. And for the other, for the blue, it is 2. So again, reciprocals. So the question is, did we just happen to pick functions where that works? So let's look at something else. So let's look at maybe a cubic. So let's try x cubed minus 1. Okay, so it's in the red and its inverse is in the blue. We have 1 already populated there, so let's look at that corresponding point. So 1, 0, 0, 1. For the red, we get 3 for the slope of that tangent line, and for the other, we get a 1/3. So let's see, is there another point that would be easy enough to look at? Let's just try 2. It's kind of off the charts for that one, but that's okay. We'll zoom in. So let's look at the slopes again. So this is 7, 2 for the inverse, and then it was 2, 7 for our function. And so the slope of that line is 12. And what we would need to check is 0.083 repeated? Is that 1/12? And yeah, it definitely is. Excuse me. Okay, so let's just take a peek back at our notes. I know we didn't really write much, but you might want to write yourself a little note, although it's going to come up here in a second. So there's a little kind of comment that Gary here has. Since the slope of the first one is change in y over change in x, and what happens with an inverse is we exchange the y's and the x's, it hopefully makes sense then that our slope would just be a reciprocal because the x's and the y's are going to switch. Okay? So there is a little bit of notation for that. I tend to feel like this is a little overly notated, and I do a little table for it, but it's a little bit different than the one Gary does. So I'm going to talk you through that as we get to example 2 and so on. But basically, we know that the slopes are reciprocals of each other. Okay, that's the big thing. If you kind of glom onto and maybe highlight there that it says reciprocal slope. Okay, so let's look at example 2. He gave us some information, but I like to put things in a table just to keep track. And you kind of have to watch the table. It doesn't really make sense to just look at it at the end, just so you know. So let f and g be inverses such that f has the function and derivative shown in the table. We're going to go ahead and I guess we have to do this multiple times, which is totally fine. So on A, they want to figure out what g prime of 1 is. So what I know is we generally plug in the x, so that's a 1 comma something. I'm going to put that in a little different place here. I'm going to put it up here. So 1 comma something, we're going to find that out here in a second. We're looking for g prime of 1. So remember over here, if the x on g is 1, then the y on f is 1 because they are inverses. So we're going to look over here at this table and figure out where f of x is equal to 1, which is when x is negative 1. Okay, so now we know over here that's when x is negative 1. We also know that the y coordinate over here would be negative 1 if we needed to know that, which I think they want us to know here in just a second. So then what we're going to be able to do is find f prime of negative 1. Again, the reason I chose a negative 1 is that's the x over here. So f prime of negative 1 is 3/2. Okay, just based on the table, and that means then that the answer to this one is 2/3. Again, we're doing all of this without even knowing the function and without even trying to find the inverse, because a lot of times we don't know that. Okay, so let's look at the next one. I'm going to use the same table, just different information now. So this next one wants g prime of 2. Okay, so g prime of 2, that means we're talking about when we have 2 comma something. We'll find that out here in just a second. Sometimes we need that something because they ask us to find the equation of the tangent line. Okay, so if the x is 2 on g, then the y is 2 on f, and so we go to the table and say, okay, f is 2 when x is 0. So I should be able to figure out what f prime of 0 is because that's the x value over here, which is 2. By the way, I could have populated that one as well. And so our answer then is the reciprocal. Okay, so let's do 3. Okay, so we're looking for g prime of 3. That's when x is 3 here. So the y is 3 on the f. We have to find that. Oh, we can't find that because there's nowhere where f is equal to 3. Okay, so we can't find that one. All right, let's go back and try g prime of 0. Okay, so g prime of 0, that's when x is 0 here, that's when y is 0 there. Oh, y doesn't equal 0 over there on my table, so can't find that one. Okay, and then let's try 5. I don't know why that's moved over there so far. Thought we had 2 more to do, but we just have 1 more. Okay, so we're finding g prime of 5. Okay, so g prime of 5. So when x is 5 here, okay, and then y is 5 there, we look at the table. Oh, good. Okay, so remember f is equal to 5, so the x is 1. And now we can find f prime of 1 is 1/2, and so this one must be 2. Okay, so on this one we might be tempted to find the inverse of the function f, but we don't need to do that knowing what we know now. And in fact, we probably couldn't even find it because there's 2 x's here. It'd be really hard to solve. So I'm still going to call this g, even though I need you to know that g is really f inverse. So I'm really looking for g prime of 28. That's a pretty big number. Okay, so we know it's 28 comma something, and we know that the y coordinate is 28 over there. So what I'm saying is that we are trying to figure out when this thing is equal to 28. Now, sometimes they make us find that out and sometimes they give it to us. So luckily here, they told us that happens when x is 3. So now I should be able to find f prime of 3. So f prime of x, 3x squared minus 2, so f prime of 3. So let's see, that's going to be 27 minus 2, so 25. So that means this one is going to be 1/25. Okay, so you don't have to use that table. It's just something I use to help keep me organized. And remember, it's at that corresponding point. So a lot of people make mistakes about what to plug into the f, but it's really the x and y are flip-flopped, so don't forget about that part.